Building quadratic functions. In this video, you'll learn how to recognize quadratic functions written in different ways. You'll also learn how to use information from a pattern of shapes to write a quadratic function. So a quadratic function is a function that includes a squared term, such as 5x squared, or x squared plus 2, or x squared plus 4x minus 1. So let's look at some examples of quadratic functions. Figure A is a large square, figure B is a large square with one smaller square removed, and figure C is composed of two large squares with one similar square added. So when we look at these images, we can see A is just that square, and B is the same square, but that one is removed, and C has two of those squares with an extra one added on. We're going to find the area of each shape if the side length is 4 units long. So if we look at the area of A, and if each side is 4 units, then the area would be 4 times 4, or 4 squared. Now if we look at area B, we'll still have the 4 squared, but we're going to subtract the 1 that's removed from the box. Now let's look at figure C. So this time we have 2 of those big boxes, so we'll represent that as 2 times the 4 squared, and then we'll add the 1 that's added on to the end of it. Now let's find the area when the length is x units. So the area of A would be x squared, and the area of B would be x squared minus that 1, and then the area of C would be 2 times the x squared plus the 1 added on. Now we'll find the area when the side length is 4x units. So the area of A will be 4x squared, or 16x squared after we simplify. So the area of B will be 16x squared minus the 1 we removed. And the area of C will be 2 times the 16x squared, which will be 32x squared after we simplify, and then we'll add the 1 that's added on at the end. And finally, we're going to find the area when the side length is x plus 3 units. So for area A, we'll have x plus 3 squared, and for area B, we'll have the same x plus 3 squared, but we'll subtract that 1. And in area 2, we're going to multiply the x plus 3 squared by 2 since we have 2 big rectangles, and then we'll add the 1 on the end. This example says if the pattern continues, what will we see in step 5 and step 18? Let's start by analyzing what each step looks like. We can see that in step 1, it just has one box in the middle. In step 2, it has a 2 by 2 square in the middle. And in step 3, it has a 3 by 3 square grid in the middle. And then each step also has 4 square boxes in the corners. So this tells us step 5 would have a 5 by 5 grid in the middle plus 4 squares in the corners. And step 18 would have an 18 by 18 grid in the middle plus 4 squares in the corners. Now let's write an equation to represent the relationship between the step number n and the number of squares y. So we can write this as y is equal to n squared plus 4, since the step number tells us how big our square grid will be, and then we always add 4 to the corners. In this example, Kieran says that the pattern is growing linearly because as the step number goes up by 1, the number of rows and the number of columns also increases by 1. Do you agree? So let's start by looking at the shapes that were given. In step 1, we have one column with 3 rows in it, and in step 2, we increase it to 2 columns and increase it to 4 rows. And then in step 3, we add one more column and one more row. So Kieran is correct that each step number does increase by 1 row and 1 column. But if we look at step 1 to step 2, we went from 3 boxes to 8, so we added 5. And then in step 2 to step 3, we added a total of 7 boxes. So since we're not adding the same amount each time, this is not linear. So we do not agree with Kieran. For our last example, we're going to write an expression to find the total number of squares given the step number. So step 1 has 0 boxes, step 2 has a 2 by 2 grid with 1 removed, and step 3 has a 3 by 3 grid with 1 removed. So it looks like we can just square the step number and then subtract 1. Even though step 1 looks like it's empty, it really would have had a 1 by 1 grid, and when we subtracted the 1, that's why nothing was left.